Hello all, we are learning the Stateflow. In a Stateflow, now we will start with a flowchart. In a previous session, we have learned about that Simulink and Stateflow are a powerful combination. Systems need to respond to both continuous and discrete changes in an environment happening. That's why we have to use Simulink and Stateflow for both. Okay, and these are some examples we have discussed. Now, we will start with a flowchart. So, basically, like here we will study about the flow chart. What is a flow chart? Before that, I will open you how we can use the state flow. So from modeling or like from simulation, Simulink library block, I have shown you from here chart. I can take this chart, drag and drop, or double click here, or anything if I did here that will work here. Okay. If I am double clicking in this chart, then I am entering into the state flow editor window. So this is my Stateflow editor window. So we already discussed all about that debug, modeling, and format and apps. Like in previously when we discussed in a detail of that Matlab Simulink window, how it will work and all these things. So I do think so. We will discuss all about that top of the part, but I'll discuss few important things which are required for this. Okay. So first is this is a toolbar, the title bar. This is a title bar. And this next is a like tool strip. This complete is tool strip. Various tools how can be accessed and all these things will be available. So this is a model browser. You can see here it's written. This is complete model browser where we can create a model, edit a model, and so many things we can do. So this is an Explorer browser that means a path where we are working. Okay, and this is a animation, like this is an example of where we can do the animation, like something we want we can take, we can add, we can do what we want to do, we can do here itself. Okay, next are like these are zoom control panel. This is like this is to be like this too. Next are these are the object plates, palettes, and all these things where we want a state or we want some junction, we want some default transition, or we want box, like Simulink state or functions, graph, truth table, history function. These are the few things which are ready to available in a Simulink, which we Stateflow we are using in a future Stateflow modeling techniques as well. Okay, so now this is like we are drawing area also we can say, and this is a status bar where we are seeing this is a ready. Now what is this, sir? And all this question will come. So this is my property inspector, and this is my some symbol panels, this types and all these things where my all inputs and outputs should be created once I have created a model. Okay, once I have created a model. So the few important things should we must need to know about the here which tool strip we are using here. So a few of the application, this is like log active activity. So this is used to records logging data of the selected state and update the simulation result accordingly. Okay. Next is like log child activity is also there. Yeah, it's there, log child activity. So log child records the logging data of the selected state, children, and update the simulation result accordingly. Another one is log active state. Yeah, there is log active state is also there. So record the sequence of a state becoming active. Okay, then there is add output port. Option is also available here, or add output port is also option is available. So create a Simulink output to monitor the state during the simulation. And we can there is one more configure login. So opens the data input, export, import, export page and of a model configuration parameter for description, like parameters like we can import and expand the configuration parameter setting. It will import we have to do right input the things. Okay, next one is like model setting that we all know about it. This option is also like open for configuration parameter also. Another one is like symbol panel. So open symbols panel of like right side. Once we open the symbol panel, it will open the right side. Here you can see in a draw area. The symbol panel allows user to manage a data. We shall discuss like symbols, symbols pan Yep. Uh, uh, like pain in a future section. Like parallel, we can discuss this involves pain in a future session. Okay, where we are creating a variable and all this thing. Okay. Fine. So property inspector, another one. We already discussed about that. Like property inspector dialog box is the right side of that. Our drawing area property inspector allows to adjust the chart properties if no other object is selected. If other object, for example, if state is selected, it will enable editing the state properties. Okay. Then what it will do is update model, update chart. These options are also available there. Then chat properties options is also available. So update mode well done. So compiles the model file and shows the warning and or errors if any. And update chart like verify the chart syntax and shows error and warnings if any. And chat properties like open the dialogs box with chat property settings like similar to the property inspector setting. It contains action language, my state machine type, update mode, and fixed point settings and so on. The options will be available here. Okay. So these are some basic important things which we are using frequently here. So that's why I have shown you, I have told you here itself. Okay. So now we can start with some basic flow chart, how we can create or something. So if I'm coming in a modeling, okay, here in a modeling, I'll get these three symbol panel, property, model, chart properties, insert subchart, pattern, and decomposition. Decomposition is somewhat exclusive or parallel, and that we will learn some future steps, future classes. So now we will learn about a pattern. So pattern means, what is the patterns? Like when we are doing a coding, writing a manual code, so we know how many patterns we are designing, like else if, for loop, while loop, do while loop, then switch case, two-way case, four-way case, three-way case. Like select pattern, like how which patterns we want. We are designing a manually, and we are writing a code for the manually. So saving up effort, Simulink given this option of pattern. What pattern will do? Pattern will give us a ready generated code where we have to give it some parameters. That's it. That's not a complicated. It's a very simple. Pattern is like ready generated code. There we have to give some inputs. Suppose if I want to know, like if my input is greater than 5, then I want to pass input as output. Okay. If my input is less than 5, then I have to pass as a 0. So in that way, I'll implement one scenario in front of you, if else logic. Okay. I have given the if else logic. Okay. Here in front of you only I have given. So now how it will work and all this thing I'll show you. So what is the description that all the thing, if I'm writing here, so it should become in a command. So what I'll write here, simple, this is an example for if else condition. Okay. And my if condition, suppose if A is greater than 5. Okay. If A is greater than 5, then B is equal to A, or B is equal to 0. Else condition will be in that. Okay. I'm making applying to the okay here. So now you can see I have get the default generated that flow chart and all this thing now. So this chart is generated and what all these things are here and all this thing. So this is like a junction. So these junctions are used here. And this is a transition. These are the transition are used here. So first transition is known as a default transition, where default transition is the starting point of the state flow. Where whatever input if you want it is coming from here, and here you can see A is my input and B is my output. So here that symbol panel is there. What I have told you we will discuss in a later, like symbol pen panel. I'll say to symbol panel this to this window, I'll right click here, A and B input and outputs are there. So now if you are able to see here, B and output is predefined selected, was according to operations, but we are making it output. Okay. And right click on here and A I'll make as an input, because A I am taking from a user and B I am giving as an output here. So from here I did, if I will double click this, so that model explorer property will open. In model explorer property, we are able to see the both the variables A and B. Suppose if I want to select a data type or something from here, okay, that should I'll work it from here itself. Okay, I'll work from here itself. A and B. Suppose if I want to select some data type, I will change to the double. For both the variable, by default data type will be double, and I am also taking double. Is there a problem? No, correct. So I am making this two variable as a double. If I am coming at a top level, so now you can see that chart is created with the input A and output B. So I will take a constant as an input here, and I will connect here and take a display as a output to see the output here. Okay, fine. So if I am passing 1, so what my condition is doing, if my A is greater than 5, no, in that scenario my A is not greater than 5, so this condition is not passed, so this action is not performed. This action is not performed. Instead of here, I will write action here also, that will work. But I have written for a simplicity, for a flow graph I am designing here. A flow graph is much more simple as compared to chart diagram. So you will design as much as simple. Okay. So when it is failed, then what will happen? That first condition will not satisfy. So you can see here the execution order after the junction. It's written here. First it will execute this, but condition is not satisfied. And that's why it is coming to here and performing this action. Where B is equal to 0 and giving us output. So this is a exit node. And this is a start point where this thing is known as a default transition. Okay, where this thing is known as default transition. Okay, this is an example of if else condition. Okay, and what I am giving an input as a 1, so output should be expected as in 0 because B is will be coming 0. So now you can see in the display once model is simulated and it result as in 0. So it's combining our result is a 0. If I was giving a value as in 7 or the chart anything said with more than 5 only I would do. Any value 3 digit, 4 digit, 5 digit, whatever if I will be giving a part of this like 6, 6, 7, 7, 8, 8 might apply. And if I simulate now, so that value I will get as an output, whatever I have here. Okay. But if I am giving some negative value like minus 5 or minus 8 something, then okay. In that scenario also I will get output as an 0 because this is also the less than 5 condition. It is not satisfying the greater than 5 condition. So here I have prepared in front of it a simple thing. Okay, for 5 also I will get output in 0 because here the condition is greater than 5. If I will make this condition to be greater than or equal to, okay, in that scenario that 5 will give as a output as a 1 because we are giving 5, the condition is greater than equal to. Now you can see I will be getting output as an 5 input same as an output. Okay, fine. So here I have designed some basic example of a flow chart and all this thing. So if you want to know more about a flow chart, what is a flow chart, a flow graph, also this thing is known as a flow graph. So flow graph is a powerful graphical modeling tool offered as part of Stateflow. A flow graph is created using a simple graphical object connection like connective junctions and transitions. Still, it can simplify the implementation of logical functionalities, which would be challenging to implement with other techniques. Flow graph elements are also essential in developing a state-based logic apart from standalone use. Therefore, we must understand how to use a flow graphs before trying our hands-on state-based logic in like we will find in state flow chart also in upcoming sessions and all this thing. At the time also we will learn so many things. What is the state-based? This is a flow-based graph, flow chart or flow graph we can say. A flow graph or a flow chart can be defined as a graphical model that is used to implement a logic pattern with help of connective junctions and transitions. A flow graph is a combination of logical compressions and basic math and loop construction. Flowchart are preferred to implement a decision tree based combinational logic in which the current decision does not depend on any other parallel state, and the decision is made in a real time without holding any memory. Using multiple junctions interconnected with a transition helps create a decision based logic. Flow graph also supports the modeling of iterative loops, switches, and custom patterns. Flow graph can also be implemented as a graphical function to be used in a modular and reusable way. So flow graphs are implemented in Stateflow chart block. Like they can be used independently or in a combination with state-based logic along with state-to-state transition. Implementation done with a flow graph is readable and easy to maintain. Flow graphs helps to eliminate and reduce the number of states in the chart, resulting its essential simulation and optimized memory used in a generated code. We shall start like familiar overseas like with the flow graph for example. Just now we have learned about that if else condition where we have this generated this if else condition how it will work and all these things. Okay. So and here we have implemented for that and all these things we have done. So here, if you want to know, this is my default transition. These are my transitions. These 4, 5 are my transition, and these are my junctions. These go circles are my junctions. Okay, these circles are my junctions. And in a curly braces, it's written. This thing is known as action. In a square bracket, if something is written, this thing is known as a condition. Okay, so like so many things we have learned here, the factor and all this thing. So for in front of you, I'll design one more pattern for an example for you. Okay. So here what we did, I'll just make this up and I'll take one more chart here. Now instead of taking from library directly, I am taking by searching the chart in Shimon. So previously I was having if else condition pattern. Now I'll make the pattern if else else if. In that way something I'll try to make a pattern. In the modeling I'll be getting a pattern here. Okay, in a pattern I'll click here. I instead of else if I'll take else if else. Else if. Okay. Or else if else. What we want we can take. If else if or else if else. What we want we like. Suppose if want is something, then we can take, and we can also hold some nested inside a loop. And so I'll take else, else if, else. This loop I will take. Okay. So I'll write here some description and all this thing in front of you. So I'll write here, this is my basic example. EXAM TNE. This is basic example. If condition I'll take C. If my A instead of A, I take now N is greater than 5. So if action should be M is equal to M. Okay, M is equal to N, else if N is less than 5. Else if condition this is, then else action, where it went? If N is less than 5, and I'll make one condition, and I'll write here and as well, no problem, and N is greater than 3 or make 2. If it's greater than 2, I will less than 5. Okay, and here I'll make a greater than or equal to 5. Okay, so condition I'll make here N is equal to I'll write something here, some like value around some 11, something I am writing here, okay, or else N equal to 0. Okay, N is greater than equal to 5, N is equal to N. If N is less than 2, if it is going less than 2, then it will become 0. And if N is between 5 to 2, then N value, M value should be the output I am taking as a M. So these are the actions I have to perform right here, M. Okay. Now here operations on N and the values M should be passed this. How we do, okay. So now here you can see it is created. Now what's my output? What's my input? So M is my output, and here I'm coming and right clicking, you can see here, and N is my input. Okay. Now I'll come outside. I'll take one more constant here, one more display here. In front of you, I am implementing everything. If you can see, if it's 5, then fine, 5 will be my output, correct? For this also, it's compiling. That's compiling. Give a second. To see the 5 is my output. If I change this value to like 8, it's greater than 5. So whatever my input, exactly same as the output. If I'm passing a value between 2 and 4, then 5, which should be less than 5, and if I'm passing a 4. If I am given an input 4, then my output should be 11. Yeah, it will come because I have set that condition here. Here you can see I have set this condition, then my output should be 11. I have written something condition. If I am passing like some 1, which is a less than 2, in that scenario, I am getting a output value as an 0. So the 3 conditions which I have implemented all are satisfying here. And if you want to see how it will come, how it will run, just you can see if I have run here the model, you are able to see that complete straight action is coming this, okay. Just for a second, you will get this image in front of you. You can see that complete straight line is blinked here. Okay, if I am making this to A, apply, okay, now you can see it will show in that way. This part is run, okay. See, you can see that there, that's shown in that way. Okay, if I'm coming here, if I'm running from inside, so here you can also see that same thing, but it will come for a blinked second. That loop should be run in that way. That condition inside is fine. These transitions are passed, these transitions are run in that way, it will run. Okay, so that's all about the flow chart and all this thing. In the next session, we will learn using a flow chart where we can make a some Coke dispenser machine or like soda dispenser, you can say in that way. Okay, so that's all about the flow chart. Thank you.